Welcome to the homework solutions video for assignment 3.07, number 1. So these are questions 6, 8, and 10 out of section 8.3 of our textbook. So question 6, sketch a possible graph of a sinusoidal function with each of the following characteristics. So we have a domain from 0 to 180, a range from 2 to 6, a period of 90, and a y-intercept of 4. So let's start building these one at a time. So first off, we are going to be working in degrees here. They asked for a domain from 0 to 180. So I'm going to change our y-axis to give us 0 to 180. Now they also asked for a range from 2 to 6. So now when we have the correct answer, it should fit perfectly into this window. So we have an a sine bx minus c plus d here, and we're going to need sliders for all of them. So right now we're not seeing anything because our graph is below this. Our y starts at 2. Now if we're going to have a range from 2 to 6, that means our midline, our d, has to be 4. Now, the maximum we have is 6. That's our midline of 4 plus our amplitude. So the amplitude has to be 2. So we're getting there. We already have a y-intercept of 4. We're close to it. So we can leave our phase shift at 0. That'll give us a y-intercept of 4. The last piece we need is to change the period. The natural period of the sine function when we are working in degrees is 360 degrees. We need a period of 90. So a period of 90 means means that b is 360 over 90, b is 4. This is our function. Period of 90, maximum of 6, minimum of 2, domain from 0 to 180, and a y-intercept of 4. So we have a is 2, b is 4, c is 0, and d is 4. Now part B, we no longer have degrees. For part B, we're going back to radians, which makes a bit of a difference in our graph. Now here we're asked for a domain from 0 to 16. We have a maximum value of 3 and a minimum value of negative 3. A period of 8 and a y-intercept of negative 3. So let's deal with these. We will set A, B, C, and D back to the defaults. 1, 1, 0, 0. So the domain is just as we have displayed here. The maximum value of 3 and the minimum value of negative 3. That gives us an amplitude of 3 minus negative 3, or 6, all over 2. Our amplitude has to be 3. There's our perfect fit with a maximum of 3 and a minimum of 3. Our period is 8. So 2 pi divided by b has to be 8. So b has got to be pi over 4. That gives us a period of 8. Finally, we need a y-intercept of negative 3, which means we need to shift the graph. And we need to shift it either left by 6 or right by 2 to get that in there. The alternative, because they did say it's a sinusoidal function, we could not shift it. We could give us a negative 3 for the amplitude, and instead of using a sine, we could use a cosine. That would also give us a negative 3. But that wraps up question 6 in the textbook. Question 8 Musab is sitting in an inner tube in the wave pool at West Edmonton Mall. The depth of the water below him in terms of time using a series of waves can be represented by the graph shown. What is the depth of the water below Musab when no waves are being generated? How high is each wave? How long does it take for one complete wave to pass? And what is the approximate depth of the water below Musab after 4 seconds? What's the depth of the water at 7.5 seconds? Assume the waves continue at the same rate. So here we're going to have to build our function based on this data. We have a maximum of 2.4 and a minimum of 0.8. We average those two, add them up, divide by 2, gives us a midline of 1.6. And we subtract them and divide by 2 to give us an amplitude of 0.8. So that's our first step. We're going to go to the sine function here. And the reason we are going to the sine function is because we are starting at our midline and increasing. So that's a characteristic of the sine function. Adjusting our previous answers, we have determined we have an amplitude of 0.8, that we have a midline of 1.6, and we don't need a phase shift because it starts at the midline here. We do need to determine the period. So if we go back and look at our original graph, from 1.6 to the next time up at that same position, we are looking at 2.5 seconds. So our B has to be 2 pi over 2.5. And now we will just sketch this. For our y-axis, we will keep it consistent with what we see on the page, which is from 0 to 3. Now they've also asked for the depth at 7.5 seconds, so I'm going to take our x up to 8, even though they only graphed it to a little after 7. So they just cut it off actually at about 6.5. I'm going to add the extra information we're looking for. So the depth below the water when no waves are being generated, that's our midline. Sorry, I didn't have that flip back. So our midline is 1.6. The height of each wave is our amplitude. That's our 0.8. How long does it take for one complete wave to pass? That's our period. It's 2.5. What is the approximate depth in the water below Musab at 4 seconds? So that's about 1.13 meters. And at 7.5 seconds, it's 1.6. So 7.5 is 3 complete periods in. So this completes our solutions for question 8. So we will set these back to our defaults and change our y back to our defaults here. All right. Actually, yeah, we should. This one should have been negative 2 pi. Okay. So now going back to the textbook for question 10. So when you exercise, the velocity of the air entering and exiting your lungs, measured in liters per second, changes in terms of time measured in seconds. The following graph models the relationship between velocity and time for an adult who is exercising. So we've got 3 questions to answer. According to the model, does an adult take more breaths per minute when exercising or just deeper breaths than an adult at rest, which is modeled in question 9. We can look to that for comparison. What characteristic of this graph has changed compared with the graph in question 9? And what is the maximum velocity of air entering the lungs? So the maximum velocity is going to be 1.2 liters per second. Although that's actually maximum speed because I'm not seeing direction here, unless you're talking about in and out. So that's part C. It is 1.2. Does the adult take more breaths per minute when exercising or just deeper breaths? If we look at these, the original period was 5 seconds, and our new period is significantly less than 5. It's more like 3. So we are taking more breaths. We have done one complete breath, and we're 3/4 of the way through the next one. So we know because of that change in period. And then what characteristic? Period, equation of midline, or amplitude of the graph has changed. Both the amplitude and the period have changed, but not the midline. The midline is still 0, which we need it to be. If the midline was above 0, then on average, we would be inhaling more air than we were exhaling, and eventually we would pop. If it was negative, we would suffocate because we'd be somehow expelling air we never inhaled. So, in this problem, we have to have a midline of 0. So that completes the homework assignment 3.07 number 1.